So let's start off with the first letter. The first letter of today, just to make sure you reach your class on time, is the letter T. Everyone write it down. It doesn't matter if it's capital T or common T, just the letter T. Right. Now I know we have this from not last week, yesterday, but let's go to quickly just spend a half a minute. Remember on your calculator, you're going to see what? Sine and cosine and tan. Whenever you press sine, cosine, and tan, well, you just get sine, cosine, and tan. The opposite of sine, cosine, and tan, right? I'm going to write it back. Everything in maths has an opposite, right? When you throw something across an equal sign, it becomes the opposite. The opposite of sine is sine minus 1. The opposite of cosine, if you throw it across an equal sign, is cosine minus 1. Anytime you want the opposite, like if you want this sine inverse or cos inverse, by the way, sine minus 1, the real name is sine inverse or cos inverse. Yesterday, I showed you to get the opposite of sine. If you have a sharp calculator, you're going to have to press the second function button first and then the sine button. If you want the opposite of cosine, you have to press second function and then cosine. For the Casio calculators, I don't think you have a second function button. Instead, you have something called a shift button. If you want the opposite of sine and cosine and tan, you have to press shift and then sine, or shift and then cosine. Also, please make sure at the top of your calculator, on the screen, you're seeing D or DEG. If you are not seeing D or DEG, reset your calculator. Some calculators have a little button here to press with a little pencil point or something. Sometimes it's at the front of the calculator. Sometimes it's at the back of the calculator. Right now, there are so many versions of the Sharp and so many versions of the Casio. If you don't know, if you're not finding those options, you're going to have to Google quickly, like type in the model of your calculator and Google quickly on how to change it to D or DEG mode. Right, but I cleared all of this up yesterday. So let's go straight into the theory part of class, okay? So one thing I did not show yesterday is how to label a triangle properly. Even though I showed everyone about a few months ago in the Monday class, I'm just going to quickly review it. Triangles obviously have two things. It's either we're talking about angles or a side. A triangle doesn't really have much of anything else. For the corners of a triangle, you must use capital letters. And you can use any three capital letters. It doesn't always have to be A, B, and C. It could be P, Q, and R, L, M, and N. But I'm going to start off simple. I'm going to call this triangle capital A, capital B, and capital C. You see, capital letters represent angles. This is angle A. This is angle B. And this is angle C. Right? So that's why it's so important to label the corners with capital letters. Once again, capital letters represent angles. The sides, we use common letters. For example, this side here, from C to B, we call that common A. You know why? Because it's opposite angle A. This side here, AB, because he is opposite angle C, you call him common C. And this side here is obviously common B, because he is opposite angle B. Now, you gotta be a little neat in your writing, right? I like to make my capital letters look significantly bigger than my common letters. Because if your handwriting is bad, won't capital C and common C look almost the same? So you will notice when I'm doing my working, just so we have no confusion, capital letters always writing significantly larger than common letters. It's not just for you. It's for the examiner to make sure he doesn't or she doesn't get confused. All right, so everyone just take down this triangle, put in your capital letters that represent the angles and the common letters that represent the sides. So this here is a side, and this here is an angle. Capital letters for angles. Let me know when you're finished, as usual. Let's see what's next here. And this is where the scariness starts. Yeah, you are seeing it correct. These are the formulas you need to deal with non-right angle triangles. This is a big, big, big difference between yesterday's formulas and today's formulas. Remember yesterday's formulas, you had these simple formulas like this. You had one for sine. If you look back in the notes, sine theta is opposite over what? Hypotenuse. It was real simple formulas. Like I said, yesterday's formulas only dealt with not with right angle triangles. Today we're in different territory. It's non-right angle triangles. Don't get intimidated as yet. Here's what I need for you all to do. Take down all the formulas on the screen, right? I will explain everything one by one as we go along. It's going to take us a long while to get this concept, right? And yes, I want you to take down the formula for an area of a triangle, right? I'll explain how to use this in a little while. And just to answer just one question. Yes, they do give you some of these formulas on the formula sheet, but they don't give you all. And believe me, when they give it on the formula sheet, it will not look as neat and nice as how I have it on the screen. So please don't depend on the formula sheet for these formulas. Learn it off exactly how I write it here, okay? Let me know when you're finished. I'm going to give you 5 minutes. It's supposed to be what here, right? I made a small mistake. Oh God, that means I have the mistake on every slide. It's capital B here, right? I made a small mistake there. If you see any other mistakes, feel free to tell me. So the box on top, right? That's this over here. The name of this rule here is called the sine rule. And the name is obvious. So look at this formula here. And you see sine, sine A, sine B, and sine C. So they call that rule the sine rule. There are certain conditions you are allowed to use that formula. You can't just use it whenever you feel like it, right? You can use it if they give you the length of two sides and an angle opposite to one of the given sides. I know that's hard to visualize, but we'll see that in action just now. And you could also use it if they give you any two angles in the triangle and any one side. So once they give you any two angles, or at least two angles and at least one side, you are allowed to use this rule, which I haven't showed you how to use as yet. So let's give you the conditions when you're allowed to use it. Right. The box underneath. The name of, by the way, the second rule is called the cosine rule. And the reason we give that, look at both formulas in the second box. And they have what? Cosine in them. So you call this rule the cosine rule. However, there are two versions of the cosine rule. And your formula sheet will not give you the two versions. But believe me, the two versions are very, very important. Now, useful, not important, useful. The first one here, you just use it to find a missing side. Remember, common letters represent sides. And you use it if they give you two sides and the angle in between the two sides. Now, that's very different from this, saying that you have two angles on any side. For this rule, for you to even think about using that rule, the angle must be in between the two sides. And the second one, you can only use it if they give you the length of all three sides of the triangle. And this rule is used to find a missing angle. I know it's a lot to take in. No worry, nobody gets this on the first, second, third, or fourth run. By the fifth example, they're going to start to be making some sense, which is scary, right? So you remember what I said. Common letters represent the length of sides. So everywhere you see a common letter, it represents the length of a side. Wherever you see capital letters, that represents the value of an angle, like 30 degrees or 40 degrees. The one on top the pattern isn't too hard to see. If you have common A on top, you have sign of the capital version underneath. So are they saying, if I had common P on top, underneath I would have what? Capital P underneath, sign of the capital P. So for the sign rule, the common letters go on top and sign of the capital version goes underneath. So that pattern is pretty easy to spot. For the cosine rule though, it's a little bit harder to spot. I don't know if you'll spot this, but I color coded it, right? If I have common A here, you all notice what touches the cosine here, the capital version, and all the other letters go in between. Like, remember, if a triangle has A, B, and C, and we're talking about A, then the other two sides are obviously what? B and C. So if I had common K here, guess what would go over here? Capital K. So in other words, the first letter and the last letter always match up, with the common letter being first and the capital letter being what? Inside. And all the other letters inside the formula will be common letters and will be the other letters, who is not A. For the last formula, if you have capital A here, then this here will be common A. This and this will always match up, with this one being the capital and this one being what? The common. And all the other letters involved go in the rest of the formula, right? But let's do some questions, right? Let's do some questions, and this will make a lot more sense. So here's what I want everyone to do. I want everyone to draw this triangle for me, right? And I'm going to do things a little different. I know all my formulas have A, B, and C. Today, I'm feeling a little adventurous. I won't use A, B, and C. I'll use P, Q, and R. So let's do that. I'm going to call this P, capital Q, capital R. Okay? Great. So let me put in an angle here. Let me call this 60 degrees, right? Here will be 17 centimeters. Here will be 13 centimeters, right? And I'm going to put a question mark over here. Draw that, and this is going to be our first question. So let's try to figure out which category we should use. We should use what? The sine rule for non-right angle triangles, or the cosine rule? One person said to use the cosine rule. Do you all agree with that? Are we using the cosine rule? I'm guessing the person said the cosine rule because, look at my arrow here, because if you read it, they said given two sides and the angle in between the two sides. Now, I agree. We were given the length of two sides. The two sides are 17 and 13. But is the 60 degrees in between the 17 and the 13? Look at it properly. That rule said you could use this cosine rule if you have the length of two sides and the angle in between. Now, if the 60 was here, Not a problem. The 60 is in between the 17 and the 13, but it's not. To me, it feels like it's this rule here. It seems I was given the length of two sides, 17 and 13, and an angle opposite to one of the given sides. Isn't this 60 degrees opposite the 17? So to me, we have the length of two sides and one angle happens to be opposite one of the other sides. So I think it's the hard sine rule. So to me, right? Well, I'm pretty sure. I say like I'm not sure, but I am sure. It's definitely this rule. All right, great. So now that we have established which rule we can use, we need to write down the formula. Now tell me something, right? What would the capital B here? If the formula, the general formula has A, B, and C, and I change the letters to P, Q, and R, can I still write the formula with A, B, and C? Or do you think I need to adjust my formulas so it has P, Q, and R? It has to adjust, right? It has to adjust, right? This is just a general template for a ABC triangle. So here's what. Let's write the sine rule for this particular triangle. So it doesn't matter which order, but I'm going to use P, Q, and R, right? And sine, remember the common letters will go on top. And the capital, I should get a little more space here. That's not. It's kind of hard to fit everything here because we have to have the formulas on the screen at the same time. So P, Q, and R, the common letters always go on top the formula. And sine of the capital version goes underneath. So if I have common P on top, I have capital P underneath. If I have common Q, here will be sine capital Q is equal to common R divided by sine capital R. You have to adjust the formula to suit the letters in the particular question. Okay? Right. So now we have adjusted the formula to suit the question. Here's the thing. You notice the sine rule has three parts. 1, 2, and 3. One of these parts is going to be useless. In other words, you're only going to keep 2. You just always have to throw away one of them. I made a not small mistake. How come no one reminded me to put in my common letters in the diagram? I have capital P, so I have angle P. I have capital Q, which is 60. I have capital R, right? Shouldn't I put in all my common letters? Won't here be common R because it is opposite angle R? Won't the 17 be common Q because it's opposite capital Q? And if here's capital P, the question mark is common what? P. I forgot to put in my common letters, but everybody in the class is guilty because no one reminded me. All right. So everyone put in the common letters. Right. Like I said, we need to throw away one part of this formula. It's either we're going to throw away the P's, the Q's, or the R's. Whatever you are trying to find is the most important thing in the question, and you cannot throw away the most important thing. Aren't we trying to find the length of common P? Because that's where the question mark is. So we're trying to find common P. So that means we have to keep everything with P. If we're trying to find P, we can't throw away P, right? We have to keep it. So we keep in P for sure. Should we keep the Q's? Ask yourself, did they give you any information on common Q and capital Q? You have any information on that? Yeah, I have the value of capital Q is 60 and the value of common Q is 17. If you give me plenty information on the Q's, like both capital and common, but I keep in that for sure because that could be useful. Did they give you much information on the R's? Look at it. I mean, they give you a common R, but did they give you capital R? Nah, they didn't give you R. In other words, who you have more information on, the Q's or the R's? To me, you have more information on the Q's. And you have to throw away one of them, right? So if they give me more information on the Q rather than R, I'm going to keep the Q's. And of course, we cannot throw away P because we're trying to find something associated with P. So guess who we throwing away? Mr. R, right? I wonder if I made a small mistake in this question. Guys, I'm going to check something here. I think I made a small mistake. All right, so the mistake is this, right? The question mark is supposed to be here. We're supposed to be finding angle R. So who do you think we should throw away? Let's evaluate. Let's use a mistake as an opportunity to, I don't know, redo the question. Who should we throw away? Right. We should definitely, since we're trying to find capital R, which is angle R, well, we have to keep who? The R's. You're finding something with R, you have to keep the R's. They gave us plenty information on the Q's. They give me common Q, they give me capital Q. Well, I keeping the Q's. They gave us no information on the P's. They didn't give us capital P or common P. And worse yet, they don't even want us to find anything with P. So exit off, right? Now I have it correct. And you will always have to do this. And once again, you will have three parts of the sign rule. You'll have to figure out who to throw away. Okay? Great. So now that we know who we're throwing away, how about we start substituting in some values? And I'm not too sure if you all remember this, but remember this thing called cross multiplication? You're going to have to cross multiply. So let me put in some arrows here and I can write it back properly. What's the value of common Q? Once again, common Q represents the length of a side. Common Q is 17. Now, you don't have to write the centimeters right now. You just put in 17, right? After the calculations, we can put the units. How much is capital Q? Capital Q is 60 degrees, right? How much is common R? Look at it here. Common R is 13. Remember, common letters represent sides. And capital R, well, we don't know him. That's the aim of the question. So here's what now. Let me write it back properly here. I have 17 divided by sine, how much? 60 is equal to what? 13 divided by sine capital R. All I did was substitute in the values. Everyone take down, well, everything, take down this and then take down this. Space is limited, right? So I have to write a little small. We want to solve for R. So here's what. At the end of the day, we're going to have to find R on one side and everyone else on the other side. Here's what I want. There are two ways we could cross multiply, right? And different teachers do it slightly different, right? How I plan to do it, sine, tan, and cosine, especially for this topic and for CXC, right? Usually I just tell you, go to 2 decimal places. For today, I want everyone to go to 3 decimal places because the sine rule and cosine rule are really sensitive. So here's what I want you all to do. I'll write in my next line here. Let's find sine 60 on our calculator, round it off to 3 decimal places, and then we will cross multiply. Find sine 60, that's regular boring sine. You're just pressing sine just so on your calculator, 60 and press equal. That's all I'm asking. 3 decimal places properly here, right? Sine 60. I get in this on my calculator. Sine 60 is 0.866. Make sure you're seeing that, right? Obviously, if you're not seeing 0.866, you calculate on the wrong mode. So no matter you need to resolve that, right? And this is equal to 13 divided by sine capital R. Once again, we are trying to solve for R. So let's cross multiply. I always cross multiply the diagonal of the letter involved. So if I'm trying to find R, I will always cross multiply that diagonal first, right? And let's make it a little space here, right? Right. So 17 by sine R is 17 multiplied by sine R. You can't really do much there. And then it's equal to 13 by 0.866. 13 multiplied by 0.866. I'm getting 11.258. Make sure you see these things on your calculator. Please, please don't just write it down. I want you to type it in and get involved in the question. All we are doing at this point is cross multiplying and trying to solve for R. For those who getting everything in like, there's something called an SD button. Look for an SD button that will convert your surds to decimals. Different calculators have different surds to decimal buttons. Great. Keep in mind, we're trying to solve for R. So we have to throw across the 17. Throw across 17, which is our multiply. You are going to get a divide. Everyone do that for me. Right? So once again, when we were up here, we just found sine 60. We got 0.866. It's just a matter. And all we are doing is cross multiplying. Cross multiplication leads us to this line here. Right? So someone says, someone is saying that if I take 13 and multiply by 0.866, the answer is not 11.258. I'm double checking, right? 13 multiplied by 0.866, my answer seems to be correct. So that person needs to try it back, okay? Just type it in back on your calculator. When we divide the 11.258 by 17, how much are we getting? 11.258 divided by 17 to 3 decimal places is 0.662. Right? Guys, just follow the working and there's nothing much more I can do, right? Follow the working, right? Everything is laid out step by step there, right? Tell me something. Are we finished? Did we solve for R? Did we solve for R? No. Remember from yesterday's class, right? I told you if you needed to solve for R, we need to get R on one side and everyone else on the other side. This is sine R. So yesterday I showed you when you throw across sine, you're going to get the opposite of sine. Of course, if you throw across the sine, the R alone remains on this side, which is what we want, right? So you get the opposite of sine is sine inverse 0.662. So type in that now on your calculator, press second function sign or whatnot, or shift 0.662. We are not looking for sine R. Isn't the question asking you to find R? Look at it here. R and then have a question mark here. If I come and ask you to find R, isn't that a significantly different thing to ask for sine R? I know I remember I asked for the value of R, not sine R. So that means if I ask for R, R alone must be on one side and everyone else must be on the other side. Right? Now, guys, over here, someone asked how I got 0.662. 662. Now, guys, I need for you all to just be a little adventurous, right? If you are seeing 11.258 divided by 17 right above, right? I needed to be a little brave here, right? You just can't ask without trying, right? Won't it make sense to say, hey, I have 0.662 here, and right above, sir, write this. Maybe I should type this in on my calculator, and see if I get it, right? You can't stop me for every little piece of working without trying first. If we do that, we're not going to finish this topic, right? So I don't mind answering questions, but you have to show me that you at least try something, or right? When I sign inverse the 0.662, right? I am getting 41, just now, 41.452 degrees. Now, for my final, remember for CXC, there is one at least 2 decimal places. I would advise, while you're doing the working for this particular topic, go to 3 decimal places. The final answer, it's optional if you want to round it off to 2. But if you leave it at 3 decimal places for your final answer, well, the examiner ain't gonna complain. You're like, hey, this person went to 3 decimal places. This person trying to be real accurate, right? But you're working in between from noticing how CXC questions go. They just want you to work with 3 decimal places within the question. At the end, you could go to 2 or 3. Right? I'm not trying to trick anybody. I'm not too sure how that is a trick, but if I truly went to 3 decimal places, I'm supposed to have a 3 here. Right, so they are correct. Right? Remember, in the formula, the common letters, or look at it for the general format. The common letters always go on top. Common letters always represent sides. The capital letters, which represent angles, will always be underneath. If you have common K on top, you will have sign of capital K underneath, right? Right, so who here, your brain is overloaded right now? Right, so everyone draw back a fresh triangle. I'm not going to call it A, B, and C. I'm going to call it K, capital L, and capital M. Okay, going to give it the length of 2 sides. Here's going to be 20 centimeters. Here's going to be, let's call this 12 centimeters. And let this angle be 43 degrees. So look at it. I gave you the length of 2 sides, just like this. And this 43, this angle is opposite to one of the given sides. So you know this is a clear case. We could use what? The hard sign rule. So I'm not trying to trick you, not trying to trick you yet. And I'm going to put a big question mark over here by capital K. So the aim of the question is to find capital K, better known as angle K. Good luck. Give it a try. You don't have to get it correct. Just give it a jump start and, see if you can get something out of it. You see how in the first question, we write down all 3 parts and then we cross out which one? You don't have to do it like that. And I train in wheels. We could clear, let me put in my common letters. I don't want to make that same mistake. If he has capital L, then the side opposite is common L. If he has capital K, this is angle capital K. The side opposite is common K. And if he has capital M, the side opposite is common M. Now, in this question, they want us to find capital K. So we know we have to keep who? The K's. And they gave us information on the M's. It have capital M and common M. So we keep in the M's. It seems to me the L's are useless. They didn't give us capital L. They didn't give us common L. They don't even want us to find L. So what you could do, right? Mentally, you could just cross off L in your head. And you're going to keep who? The M's and the K's. So you could just start off here. You can put common K divided by sign capital K. So all right, in the capital K is significantly bigger than the common K, right? And common M divided by sign capital M. Now, I know someone is going to ask, if I put the M's first and the K's after, is it still correct? Yeah, it's still correct, right? Right? I always like to go in alphabetical order, right? K comes before M, so I'm going to put the K before. How much people at least had that formula? Like somewhere in your book, you had that formula. And it's just a matter of what now? Right? It's just a matter of filling in your values, right? So it may help you a little bit. I don't want to work it out completely yet. Common K is 12. Capital K, but he's a question mark. We don't know him. He's the aim of the question. Common M is 20. Capital M is 43 degrees. Substituting your values, remember, when you're finding sine 43, round off to how much decimal places, how much I advise, 3 decimal places, and then cross multiply. Take a minute again, and I will jump in after. So let's take this step by step, right? We have 12 divided by sine capital K is equal to M is 20, and then we have sine 43. Now, I run out of space here, so I'll be continuing on top here. So I have 12 divided by sine capital K divided by 20. Now, I had advised before you cross multiply, you can work out sine 43 on your calculator by just pressing sine and 43. But round it off to at least 3 decimal places. Sine 43. I'm getting this. Now, obviously, now I just let you know, right? If you round off bad or you didn't round off the 3 decimal places, obviously your final answer will look different. And I know a bunch of people are going to ask me if it's right, if it's still right or wrong. In my book, I'm considering it wrong because we had an agreement in class, right? We would go to 3 decimal places, right? So sine 43 is 0.682. We can agree with that, guys? 682, because the next number was 9. So we had to add 1 to the 1. On the right track? On the right track? 0.682. Great. Lots of people are agreeing. Good. So it's just a matter of cross multiplying. We want to find K. Let's cross multiply this first. Sine K multiplied by 20 is 20 multiplied by sine K. Now, I like to put the 20 before. Some people put sine K multiplied by 20. Try not to do that. If you're multiplying a number by sine, tan, or cosine, put the number first, right? It does prevent the calculator from making an error sometimes. Okay? Great. Let's multiply 12 by 0.682. 12 multiplied by 0.682, I'm getting 8.184. Hoping that you all see that somewhere in your working. Double checking my answer. 12 multiplied by 0.862. Remember, the aim of the question is to solve for K, angle K. So we need to get K on one side, and everyone else on the other side. Draw across 20, which is our multiply. You're going to get what? A divide. So sine capital K, when you divide this, right, by 20, you're going to get 0.409 to 3 decimal. And I know some people have that because They sent this by mistake rather than the final answer, but we're not quite finished. Remember, we want to solve for k. So if you want to get k on one side, you throw a cross sign and you get what? Sine inverse 0.409. Let me see if you guys are correct there. Second function, sine 0.409. And you guys are correct. 24.142. That's the what? 3 decimal places. And remember, I gave you the option of putting it to 2 if you wish. Right? Now, like I said, if you round off even the slightest bit different from me, you might get something slightly different, like 24.2 or something, or a little bit off. If that happens, at least you have the concept correct and you know the steps. It's just your rounding off was wrong. So congrats to the people who got 24 point anything. Let's try another one. Let's change up the letters. How about X, Y, and Z, right? I like to write my Z with a little slash in between, so it doesn't look like a 2. Right, so let's see, we'll give it this angle here. I'm going to give it this angle as 33 degrees, right? Here is going to be 41 centimeters. Over here is going to be 28 centimeters, right? And your job is to find angle X. Notice you have the length of 2 sides, and one of the given angles is opposite to one of those given sides. It's still the sine rule for non-right angle triangles. Good luck. Bye. So I should put in my common letters. Let's see. Common Y, common X, common Z. The Y's have nothing to do with this question. We keep in the X's because we want to find the X, and they give us plenty information on the Z's. So I like to keep everything in alphabetical order. Common X divided by sine capital X. And over here we have common Z divided by sine capital Z. So it's just a matter of what? Substituting in what? The values now. Common X, the one, remember common letters, the ones on top will be the length of sides. So common X is 28. We're trying to find capital X, so let's put sine capital X. Nothing much you can do. Z, where's Z? Common Z is 41 divided by sine capital Z. Capital Z is the angle. How much people have up to there? Great. Remember that sine 33, right? This sine 33, I'm going to find them on my calculator and round them off the 3 decimal places, right? I'm going to get red. These are different color. Getting boring here. 23 divided by sine X is equal to 41, and sine 33. Sine 33 to 3 decimal places is 0.545, not 44. If you round it off properly, it's 45. I'm double checking it. 1.545. Correct. Time to do what now? Cross multiply. So let's cross multiply. Right? Somebody said I made a mistake. Oh, put 20. Oh, sorry. It's 28. I put 20. Sorry. I'm getting tired. It's 28. My mistake here. My mistake is 28. 41 by sine X is 41 multiplied by sine capital X. And 28 multiply by 0.545. That's 28 multiplied by 0.545 is 15.26. We want to solve for x. Don't forget the aim of the question. 41 is a multiply. Throw him over, you get what? A divide. So sine capital X over half everything. When you divide the 15.26 by 41, you're going to be seeing 0.372. Double checking it. Someone said it's wrong just now. 28 by 0.545. Now it seems correct. 0.372. Keep in mind, we want to solve for who? X. We don't care for sine X. We want X alone. The aim of the question is to solve for X. So that means we grab sine, throw him across. Sine inverse 0.372. Let's see if you guys finally got it correct. Yes, plenty people sent this way before me. 21.839. Obviously, I've given you the option to go to 2. Right? Anyone is correct. If you got that without my help, obviously feel very, very proud of yourself. You notice in all the questions so far, but obviously we use the sine rule. We didn't use the cosine rule. For all the questions so far, we were finding a missing angle. Look at all 3 questions. We use the sine rule to find a missing angle. We're going to try our next question now, where we're using the sine rule again, but we're going to try to find what? A missing side, because not all questions that come at an angle will be missing. Maybe one day you have to find what? The side. A side, sorry. All right, so I'm going to erase everything now. I'm going to adjust the question. Okay. Let's use 3 more letters. D, E, and F. Now look at this. This time it's going to be this situation. We are going to give you 2 angles and one any side, right? So I'm going to give you 2 angles. Let here be 60 degrees. Let here be 34 degrees. And I'm going to give you the length of one side. So I'm giving you 2 angles this time and one side. So let over here be 38. I'm going to go with meters this time. And the aim of the question is to find this question mark. You want to find the length of this side. Everyone draw this, and I'll give you a little jump start on this one. Right? This time it's a missing side, but according to the conditions, it's still the sine rule. Right? At least let me know when you finish drawing it, who is useless in this question. One person will always be useless. People already said the useless letter, right? The useless letter is obviously going to be D. If he has capital D, the side opposite is common D. If he has capital F, the side opposite is common F. If he has capital E, is common E. Right. So we realize, wait now, they didn't give us any values for capital D or common D. They don't even want us to find anything related to D. So I'm keeping that around 4. Right? So we're not dealing with the D's. So we keep, so this is what I used to do, right? If I know I'm not dealing with the D's, you know what I used to do in the exam? I just cross out everything with D, so I don't ever look there again, right? And of course, that's a good practice, right? So let's write the formula. It's E and F. E comes before F, so you know me. I like to go in alphabetical order. Common E divided by sine capital E divided by F divided by sine capital F. I guess lots of people had that formula down, right? They just eradicated the D's. D's had nothing to do with it. How about we start substituting in some values? Now, this time we have two angles. You notice they give us two angles this time. I'm going to do this one a little bit slower since we kind of new to it, right? Common E is how much? Well, we don't know common E. That's the aim of the question. So we just write back common E. Sine capital E. Sine, what's the value of capital E? 60 degrees. Common F. Common F is 38. And then we have sine capital F, which is 34. We okay so far, guys? It's just a substitution of values. Right. Now, before we cross multiply, you notice, and we could find sine 60 in our calculator, and we could also find sine 34. So why not find both of these to 3 decimal places and then do what? Cross multiply. How about that? So we have E, and here you have 38. Find sine 60, rounded off to 3 decimal places. Find sine 34, rounded off to 3 decimal places, and then we could cross multiply and solve for common E, which is the aim of the question. Sine 60, I'm seeing 0.866 on my calculator. And sine 34, I'm seeing 0.559. Great. Now, this one will have no sign inverse. Look at it. It have no more signs, or all the SINs disappear, right? So it's just a matter of cross multiplying. You get E multiplied by 0.559. And then you say 38 by 0.866. 38 multiplied by 0.866. I'm getting 32.908. You just need to solve for E. Remember, you want E alone on one side. So this 0.559 is a multiply. Throw it across and get what? A divide. All right. Some of you are putting the answers on the screen already. And if you saw anything close to this, 58.869 meters, you are correct. Or remember, you have the option of going to 2 decimal places. Oops, that's not an M. That's, you know, that's supposed to be. Look through the working, look for any. I didn't see any wrong answer. I saw one wrong answer, but I'm sure the person corrected by now. Oh, another question, right? Right. I didn't get a chance. Someone's asking if we have any games to play today. Oh, Lord, I don't think we can play games today with this particular topic now. I think everyone would we needed every single second for today. Right. Oh, another letter. Today, the third letter, to make sure we're paying attention. The third letter is the letter A. So that means we have 3 letters down so far. 3 letters. Right. Right. Now, remember the rules of using, right? When it comes to the hard sign, the sign rule, these are the conditions you're allowed to use it. Now, whether we're trying to find a side or an angle, it all depends on what the examiner asks you to find, right? He'll make it very clear. Hey, find this angle, or, find that missing side. But the first thing you need to do It's, well, look at the information he gives you and then say, all right, am I allowed to use the hard sign rule? And if the answer is yes, you just figure out who is useless, plug in the values you have, and cross multiply. If you're trying to find an angle, you will always end up finding sine inverse. And you don't even have to remember that. If you're trying to find an angle, the question will force you at some point, twist your hand at some point to find the sine inverse of something. If you're trying to find a regular boring side, just like now, you notice there was no sine inverse in the question, but the question will naturally flow in that direction, right? So it's not a matter of knowing at the beginning of the question whether I'm going to have to use the second function button or not. The question guides you on what to do. It naturally flows in a certain direction, right? So let me plug in some values here. So I'm going to give you two angles. How about for the last question, we use A, B, and C. I've seen it like the last question, like hopefully we have more time, obviously. I'm going to give you the length of, I'm going to give you two angles now. Here's going to be 48 degrees, and this angle is going to be 70 degrees. And I have to give you two angles and one side. Let here be 72 centimeters, and you have to find this side here, right? And this topic is, well, it's still trigonometry from yesterday, but it's non-right angle triangles. Yesterday we dealt with right angle triangles. Today is non-right angle triangle. Let me put in the common letters. Here will be common C, who we know is useless. Here will be common B, and here's common A. So they want us to find A, so we keep in everything with A in it. They give us a lot of information on the B's, keep in that. Cross out C. Physically cross them out so you don't pay attention to that or make the mistake of writing it down. Formula is common A divided by sine capital A is equal to B divided by sine capital B. And I trust everybody has up to date. It's just a matter of substituting in the values now. Common A, right? We're trying to find common A. So we're trying to find the length of a side. Sine A. Capital A is 48 degrees. Look at there. Capital A. Capital A. Common B. 72 divided by sine capital B. That is 70 degrees. Capital letters represent angles. Now look at, before we cross multiply, we should work out what we could work out on our calculator. So you see in sine 48. So type in that, round it off to 3 decimal places. Type in sine 70, round it off to 3 decimal places. Then cross multiply. You will notice this question have nothing to do with sine inverse. The question will get, right now, when you sine the 48 and sine the 70, all the signs are going to disappear from the question. So there will be no sign to throw across to get the inverse. Sine 48, 0.743. Sine 70, 0.93. Well, look at this, and this one's a strange one, because when you find sine 70, you're getting 0.396. Now, if you add 1 to the 9, you get 10. which means you have to add 1 to the 3 now. So you'll get 4, right? So you get 0.94. You don't have to put the 0 after. You can put the 0 after if you wish, but it's not going to make a difference, okay? So that one was a strange one if you went to 3 decimal places, which is what we agreed to in class. So if you made a mistake over here, please just rectify it. 0.396 to 3 decimal places is 0.340. Like I said, you don't have to put the 0 at the end of the 4. Won't make a difference. Cross multiply now. Take A, multiply it by this. A multiply by 0.940 optional. 72 multiply by 0.743. 72 multiplied by 0.743. I'm getting 53.496. Almost finished. We want to solve for common A. Grab this, multiply, throw it across, you get what? I made a mistake. Anybody said I made a mistake? That's all. Anybody see any mistakes here so far? I'm gonna double check my working. Great. Let's divide it. 53.496. God, calling all these things so tired out. 0.940 is 56.911, right? So, and if you go to 2 decimal, this is to what? 3 decimal places. Or if you go to 2 decimal places, you get 56.91. All right. Right. Remember, I explained already how, well, I think I did it like 3 times. How, not 3 times, 2 times of how I got this. I showed how I rounded this off to get the 0.940 to 3 decimal places. All right. All right, so if you got this out, a lot of people did get it out without my help, and the answers was on the chat way before I could work it out. So I know a lot of people got the